Can you see the screen now? Bharat Singh. Deepthi?
Yes, sir.
Can you see the screen now? Repeat it.
Yes, sir.
Okay. Right. Okay. Right. So in the last class, we discussed about the application of earth science in civil engineering practice, the mapping, tunneling, and exploration part. Bharat, mute your Bharat.
Yes, sir.
Okay, mute madabana. Bharat Singh. Okay, that's good. Now it's clear. Okay, so let me start this. Okay, the next topic is that it's the internal structures of the earth. Right. So what is there in the internal structures of the earth? So all of you maybe have seen the surface of the earth. So what are the features are there? What are the features in the surface of the earth? What you have seen there? Anybody can? Muhammad Sanif?
Yes, sir.
The surface of the earth. What are the features are there?
Mountains, rivers.
Correct. Right.
Soil, sir.
Sarath Kumar, correct. Right. That's right. Sarath Kumar. Sharath Kumar.
Yes, sir.
Tell me. What's there? Shraddha Patil.
Sir,
What is there on the surface of the earth? What are the features you can see that? Maybe all of you have seen the topo sheets, right? Topo sheets in the 10th standard, I think. Right. What are the features you can identify from the topo sheet? The same thing you can identify from the surface of the earth. This is surveyed map that is actually is there. Siri Gatimani. Hello. Tarun. Hello.
Yes, sir.
What is there in the surface of the earth? What you can see there? Hill, valleys, river, road network, railway, reservoir, right? What else you can see there? Hello? Sampath. Sampath, yes. Rohit? Yeah, Sampath, tell me.
Hello?
Yes, Sampath. What you can see on the surface of the earth? What are the features? Rohit? All right. So on the surface of the earth, you can see the mountain, hill, valleys, small maybe streams, first order streams, second order streams, and the river, dam, road, railway network, villages, towns, and what else you can see there? Power lines. How many things are there in the surface of the earth? Right. What about the subsurface? What you can see there? In the internal structures of the earth. This is the most important. In the in the exam. Actually, there will be a one question always. Most of the time, it's one question will be there from the application of earth science in the civil engineering. That's the first question. Next question may be in the internal structures of the earth. Okay, so there are three major layers in the internal structures of the earth. The first one is topmost layer, that's called crustal part, and next one is the mantle, and third one is the central part of the section called core. Okay, crust, mantle, and core. And again, the mantle, the upper mantle and lower mantle, you can classify that, and the core central part is also divided into two parts. One is the outer core, and next one is the inner core. Okay, so this crustal part, most of our the minerals and rocks occurs on the crustal topmost layer of the earth. It is about 35 to 40 kilometer depth from the surface. From the surface, 35 to 40 kilometer of the depth. Okay, and down below there is a called mantle, that's upper mantle, and that lower mantle, that is about 2,700 kilometer. Okay, and below that, from there, 6,173 kilometer. When you reach it to the the central part here, this is a topmost layer. This is a crust and mantle. Here you can divide this upper mantle and lower mantle. This is up to the 2,700 kilometer, and this is the what you call core, central part of the earth. And again, we have divided into two parts. One is outer core, and another one is inner core. If you cut the apple, you can see the structures here like this. The top red one is the crustal part, and middle one is this, and central part you can see this. You can easily identify. These are the three major structural layers in the earth, internal structures of the earth. Okay, and next one is that. So how we are going to on what basis these structures are classified? I mean, divided. Yes, up to 30 to 45 kilometers. Sorry, 40 kilometer. It's a crustal part. Okay, and the next one is the mantle part. It's up to 2,700 kilometer. Okay, how we are going to guess that? On what basis you are saying that it's up to 40 kilometers a crustal part and the mantle part? And okay, this is based on the seismic survey. Based on the seismic survey, we have divided the internal structures of the earth into three parts. Okay, there are P waves and S waves are generating when we are conducting the seismic survey, right? Based on the primary waves and secondary wave velocities, reflection, refraction, and some more absorptions. Based on that, we have classified the strata. Okay, so these are the main basis. Okay, seismic survey. Right. So let's go into the next part here. Yeah, you can see this. This is the surface of the earth. Okay, thin continental crust here, and very thick of continental crust here up to here. This is a topmost, and this is an internal one. Okay, and here is the normal continental crust. This is a topmost layer, and here is a topmost. And in between, there is a chord in between somewhere here. I would say it's a Gutenberg discontinuity is there. That also they have identified more discontinuity, Gutenberg discontinuity in between the layers, mantle layers. Okay, so here this what you call this internal structures based on the seismic survey, right? So upper mantle, lower mantle. Okay, so it's 2,900 kilometer from there. This is a crustal part. Okay, and here is the transition zone between that, and next is the core, and this is 6,371 kilometer from top surface of the earth to the central part of the earth. This is all about the internal structures of the earth. Okay, so if you cut the what you call watermelon, or you can apple, you can see the maybe exactly the same layer. It may be the variation will be there in the color variation. Okay, but the structures you can see this from these two fruits. Okay, internal structures of the earth. So all you need to understand is how the internal structures of the earth you can see, and what are the different layers, and each layer have the different minerals. The crustal part is having the different minerals, mantle part is having the different minerals, and core part, central part is also having the different minerals. Okay, and based on the minerals and rocks, reflection, refraction, and absorption of the seismic waves, we have classified this. Okay, most of the the crustal part is having the heterogeneous materials. Okay, for I give the example of mining, especially the open cast mine, underground mines, open cast and underground mines. Open cast may go up to maybe the 100-meter. That's the maximum. That's too difficult because boundary extension is very difficult. So maximum 100-meter you can go. Okay, behind that, so difficult. If you have a more land, you can go about that. So if you are taking the underground mines, say for example, coal or gold field, that has gone up to the I think 3,000 feet. Okay, I think more than that. Okay, that's the second deepest mine in the world. Okay, now 1,200 feet, the Hatti gold mines has gone up to there. Okay, Hatti gold mines. From the mineral extraction point of view, mining point of view, it is only the maximum open cast mine 100 meters. Underground can go up to 1 kilometer down below that. Behind that also they can go based on the capacity of the machineries, safety precautions, and based on the budget. If you are going deeper level, you will get more and more. You need to take more and more the precautions, safety precautions. You must have the more budget for that. That's the thing. And when you come to the what you call the oil and gas exploration and exploitation of the oil and gas, still we are in the crustal part only, because crustal part is the 30 to 40 kilometer thickness. Till we didn't reach 10 kilometer. We reach up to the 5 to 6 kilometer for oil and gas exploration and exploitations. Generally, for oil and gas exploration, we used to carry out seismic survey. Again, that is based on the primary waves, secondary waves, reflection, refraction, and absorption of the the velocities of the waves. We are deciding that, we are assuming that, we are assessing that, we are doing the interpretation based on the this what you call waves. We are guessing that okay, at 100-meter depth, this is a thickness. I mean, this material may be having that, and behind that, this is the thickness. Based on all the indirect methods, these are all indirect methods. These are all, we call it as a geophysical survey, right? Geophysical survey, there are different types of geophysical surveys there. One is resistivity method that I told you in the morning. For groundwater exploration, we are doing the geophysical survey. That's the resistivity survey. Okay, don't get confused that. So we are doing the exploration part. For doing the exploration, one is geophysical survey, that is an indirect method. We are sending the signal to the subsurface. We are collecting the, the recording the informations, and based on that, we are doing the interpretation part. So now we are at the oil and gas exploration. We reach up to the only 6 kilometer, 5 to 6 kilometer, not behind that, I guess. Not behind that. Up to 6 kilometer, we reach there. Okay, and then, okay, there, right. So, and then the next part is that crustal part, we reach up to the, not even reach up to the 10 kilometer or 15 kilometer. Okay, so now we are in the next stage. Because of this heterogeneous material, you can get the iron ore, gold, copper, lead, zinc, and different rocks, granite, cyanide, dolerite, basalt, everything on the crustal part. Okay, even if you take the igneous rocks, sedimentary rocks, or in the metamorphic rocks, we are in the this layer now. So still we are in the crustal part. We are not each of them. Because of this, it's a heterogeneous material which is having this rich of almost all the metals there. And we have the water, we have the things. So when it comes to the second one, let's go to the part. Okay, bulk earth composition, how it was. Iron, oxygen, magnesium, and silicon percentage, and other materials, right? So here you can get the clarity on the crustal part. What is there in the crustal part, right? So it's a topmost shell, I'd say that. It's a topmost shell of the earth crust. Okay, thickness is 30 to 40 kilometer, and the contents of 5 to 6 kilometer in the ocean part. Okay, this is a oceanic crust and this is a continental crust. There are two. They show in the first picture, I think, is imagine there. Yes, continental crust. You can see this continental crust thickness about this lithosphere. Okay. Okay. Say the oceanic crust is made up of heavier and darker rock called basalts. The 50% of silica percentage in that. Oceanic crust made up of heavier and darker rock called basalt. Okay, and the continental crust, which is made up of light and gray color, it's a granitic rocks. It's a 60 to 65% of the silica. Okay, and alumina is 13 to 16%, and iron oxide is 8%. And again, there is a lime, 8%, and sodium is the 4%. Magnesium is the 4%, and potassium is 2.5%, and titanium is 2%. These are all about how you are guessing. Yes, only the alumina is 13 to 16%. Iron oxide is 8%. Okay, how you are come to this conclusion that is based on our seismic survey data, interpretations. Okay, so other than that, we don't have the data to guess it. Seismic survey is the survey which can penetrate more than 5 to 10 kilometers based on the instrument capacities. Okay, so far we reach 5 to 6 kilometers, as I told for oil and gas explorations. Okay, that is the thing. Based on this seismic survey results and the interpretation, okay, we guess that crustal part is 30 to 40 kilometer thickness. Okay, in that 5 to 6 kilometers is the ocean part. And again, there is a 50% of silica in the oceanic crust and 60 to 65% in the continental crust. That's the granites. Most of you people are seeing the granites and as well as the basalt. Okay, so here these are the chemical composition of crustal part of the earth. In the exam, you need to write in such a way that if you ask the questions generally, what is the internal structures of the earth, with any diagram, you need to write down this diagram first for the different layers in the internal structures of the earth with the what you call this lower mantle, upper mantle, and crustal part and central part. So you need to draw this diagram, and then you need to write down all this, describe the chemical composition of the crustal part. Okay, let's go to the okay. Yes, that's a C material. Yes. So in the crustal part, further there is a the more than what you call this here. Here we are limited of iron and lime, sodium and potassium, magnesium. So here, other than this, there are many number of this. So here are elemental composition reflect mostly the heavier minerals. It's all heterogeneous. I would say it's heterogeneous minerals. Okay. So most common minerals consist of silica, mixed having the proportion with the elements of iron, magnesium, alumina, sodium, and all those things. Okay, there are called felsic, mafic minerals. Don't worry about those things. That's a deeper level of geology. Just you need to understand what is the internal structures of the earth and what are the chemical compositions. Okay, that's all about this. So let's go to the mental part of the central part of the sorry, the middle part of that. It is having the homogeneous material till the depth of 2,900 kilometer. Okay, it's a homogeneous materials. What is the material there? What type of minerals, what type of rocks are there in the mantle part? See, it is having the extremely basic material called ultrabasic rocks. So what is there in the ultrabasic rocks here? Mafic, felsic, and ultramafic rocks. This is about 30 to 35% of this out there. Okay, so here extremely basic material called ultrabasic rocks, rich of iron and magnesium. Okay, and very poor in silica, percentage here. Okay, and high densities. Okay, and it increasing steadily with the depth. Okay, and still it is in the high plastic nature. Okay, and so most of this earthquake, origin of the earthquake, and from formation of mountains from this mantle part of the earth. Okay, origin of the earthquake happened from the mantle part. Maybe it's coming from the 2,900 kilometer down below the earth, or it may be just 50 kilometer down below the earth. It depends on the plate tectonics collisions. Okay, next part is that core. This is the central part of the earth. Again, we have divided this into the two parts. One is inner core and outer cores. Okay, it is the third and innermost structure shell of the earth. Okay, and clearly marked seismic survey evidence. Okay, and the depth from 2,900 to 6,370 to 71 kilometer center of the earth. Okay, and there has no shear resistance here. The material has no shear resistance, and it's almost near to the liquid. Okay, and it is having the high densities, very high densities in the central part of the core, and this core is made up of iron and nickel and other alloy materials. It is near to the liquid, semi-liquid, the state of there still. Okay, and which is made up of iron and nickel of alloy materials. Right. So these are all the different what we call the internal structures of the earth. Okay, and, okay, that's the things. So when it comes to the next class, okay. Right. So here you can see this. This is how the seismic survey generally used to carry out in the offshore. Okay, so here is the seismic survey vessels. It may be a small boat, depends, or a big ship. It carries the many manpower, machineries, and many things are here. Survey equipments. This we call it as a seismic survey vessels. Hello, Sampath, Shraddha, Sharat Kumar. Hello, can you hear my voice?
Yes, sir.
Sir.
Clear? It's clear, or any
Sir.
disturbance is there?
Sir.
Clear, huh? Okay. Right. All right. Right. So this is okay. This is what how the seismic survey conducting survey for oil and gas. Huh? This is for oil and gas. Generally, we used to conduct this. Okay. For okay, this is a seismic survey vessels, and here is the I would say it's the air gun. Passing the pressure waves. So starting generating from this here. This is completely the water column here. From here is the water column, and down below this seabed sediments. Okay, and below that there is a solid rock. Okay, very hard rock. You can see that, right? So, and each column, say water column behaves differently, and seabed sediments behaves differently. The solid rocks also behaves differently here. Okay, so when you pass the pressure waves through the different mode of formations, okay, some of the rays or the waves are reflecting, some of the waves, or what you call this absorption will be happening there, and partially reflection, partially absorption. Those things can happen here. This is a one ray coming from the waves coming from the air gun, and you can see here how many, 1, 2, 3. One is reflecting with a very shallow depth, and another one is reflecting from the deeper level, and another is reflecting from the very deeper level. Okay, so here in the water column, the pressure waves are easily passing there. Okay, and when it comes to the seabed sediments, this is a small thickness of the seabed sediments. So here some waves are not reachable because sediments, there's a loose strata is here, and easily you can of course I would draw this somewhere here, 1 or 2 rays are reflecting somewhere here. Okay, and the solid rock, because of the solid rock, it's not going to absorb any waves. It gets reflected, it's reflected back to that, and these waves are recording reflected waves, reflected pressure waves are recording in the streamer, hydrophone streamer. That's an instrument called hydrophone streamer, which is receiving and collecting the informations. These are reflected waves, pressure waves. And this type of survey generally used to happen for oil and gas in the offshore. Okay, same thing we do for the what you call in onshore. Okay, right. So here, one thing you need to understand: same the principle and same method we apply for to classify the internal structures of the earth, the crustal, mantle, and the central part of the core. Based on this type of survey, say igneous rocks are completely behave differently. I mean the waves are maybe reflecting, igneous rocks completely reflecting. Sediment rocks, the sediments is grains. Okay, the sediments are partially reflecting, partially absorbing, 50%, 50-50, or it may be 60-40. Depends on the formations, depends on the clay content in the sedimentary rocks there. Okay, based on that, the waves are reflecting, refraction, reflecting, or absorption. This can happen in the seismic survey method. Okay, especially in the igneous rocks, solid hard rock formations. Generally, the igneous rocks are very solid, high hardness, and it's a very fine grain. Due to a very fine grain, there is a high hardness. So in the sedimentary rocks, generally it is a low strength and connected to the orient. So this is all about the what you call this. Seismic survey methods, seismic survey operation for potential source of effect from the earth source. Okay, these are all the pollution, this ones, safety precautions, atmospheric emissions, combustion emissions. These are all pollution. This is another topic for that. So accidental safety precautions, wastage returns, okay, and their interaction with the different layers, emission to the seas, those things. This is how we are going to conduct that. And all about this, this is an indirect method. We don't know that what is happening in the down below the earth. Just we are sending, just we are passing the pressure waves, and we are getting the some reflected waves in the different time. Okay, velocity, time. Based on these two, we are going to assess whether it's a sedimentary rocks, whether it is a igneous rocks, whether it is in a fractured zone in the down below the earth, where there is a the oil traps can easily find out there, where there is abnormal readings, where there is the readings are highly fluctuating, sudden change in the velocity, sudden change in the pressure waves. There we can identify or do the interpretation part. Yes, there is a oil traps are available, oil traps, oil pockets, would say, oil reservoir. We can say that. I would say it's a oil reservoir or oil pockets. This is how we are doing the what you call this seismic survey. This is all about the internal structures of the earth and how we are going to divide it or classify the different layers based on the seismic survey data. Okay, this is all about the today's class. So we'll continue in the next class. I think it's 11:50. Who's going to take the next class? Manoj? Okay. Hello? Madan Kumar?
Yes, sir.
Okay.
Strength of
Okay.
materials, sir.
Okay, right. So I think all of you enter the your attendance in the chat box. I hope. I guess that. Okay. Thank you very much for the session. Right. Thank you.